Hi, welcome. Really excited to have you all here today. So, we're going to talk about smart contract development on Polkadot, specifically using PopCLI tools. So, those of you who are new to PopCLI, I already have it installed. I can just say pop-help, and you'll see the list of commands, right? So, PopCLI is a tool for Polkadot development. Specifically, it's got two tracks. One is smart contract development with Ink. Ink is a smart contract programming language for Polkadot. And the other track is app chain development for Polkadot. All right, so today we're just going to show you how to build a smart contract, something simple. So pop new contract. We get a list of templates, template providers, and you can see there's ERC, ERC20, for example. There's some example templates, like if you want to learn how to do cross-contract calling on Polkadot with Ink, there's a template for that. You can play around with the different templates. Today we're just going to do a hello world template. It's called Flipper, and I already created that command already created the contract, so it's already there. I can open it inside of VS Code, and there's Flipper, right? So we just generated an Ink smart contract. You can see in the cargo.toml file, there's the Ink crate, specifically Ink version 5. Okay, and it's called Flipper. And if we look at the code, there's Flipper. So Flipper is the most basic smart contract you can think of. It has inside of its storage, it has a value that's a Boolean type value. So the value could either be true or false. And it has a function called flip, right? So it takes whatever's in storage. If it's true, it'll flip it to false. If it's false, it'll flip it to true. And of course, we can also read the storage value. Okay, so let's get this started. I want to actually build the contract. So pop build, and it's going to build a contract. We have a constructor here. So there's a new constructor. It accepts a Boolean, and that'll set the state for the contract. Okay. We also have a default constructor, and it'll default to the Boolean type false. Okay, so there's two constructors actually. Today, let's see if we can call. Let's try to upload the contract to a chain, a blockchain, and then call it. Okay, so that's building. You can see there it's compiling. So those of you who are not familiar with Ink, Ink is essentially Rust with macros. So you can see there that it's compiling the different crates. It's done. It's pretty cool. The WASM size, 35.3 kilobytes. It's optimized to 10, so it's pretty small. We compile in debug mode. That's great for development purposes. And we got some output, right? So if we look in our target folder, inside of Ink, you can see there's flipper.contract, which is the metadata for the contract, plus the code. We have flipper.json, which is simply just the metadata, like what's the interface of the contract. And then we have the flipper.wasm, which is simply the code for the contract, the logic of the contract. Okay, so let's upload and instantiate this contract on a blockchain. So there's a command called pop up contract. If I say --help, we can look at the parameters. You can see up here, pop up contract, deploy a smart contract. And by default, it calls the new constructor. So I don't need to necessarily specify this flag, this option here, but I will need to specify the argument to the constructor. The other thing to note is that by default, for development purposes, if there is no RPC node specified, it'll default to localhost :9944. Okay, so we're going to take a look at that. Actually, let me type the command in. So pop up contract --args. We're going to initialize it to true, the initial value, and the default is localhost :9944. No endpoint was specified. Would you like, so it detected, PopCLI knows like that there's nothing running on that port, and it's asking us if we want it to spin up a blockchain node that's compatible with Ink smart contracts. I'm going to say yes. and it's starting the blockchain node. It's a substrate-based blockchain node. And look at that, it's already deployed and instantiated. So the contract is live. There it is, there's the address. So I'm gonna copy that. Would you like to terminate the node? We'll keep it alive, let's test it. So now I'm gonna say pop call contract, right? So let's look at that real quick. So pop call contract allows us to interact with our smart contract, and we can specify the contract address with this option, the message that we want to call. So for example, let's try to call get to read the state of the contract, and other options are available as well. So I'm going to say, okay, so pop call contract -- contract, paste the address in that we just deployed it, right? And we want to call the message get. So if we look at our contract, we have the get right there, right? Get. So it should return the value that's in storage, which if you remember, we instantiated it true. So we should get back true, all right? So I'm gonna hit return here. And we got back true. So we got a result true, that is correct, like that's what was expected. So one thing to note here is that it says your contract has not been executed, which is correct, right? We're just reading state. For reading state, all we need to do is PopCLI will connect to the RPC node, localhost 9944. It'll read the state of the contract. It'll return the value. So there's no need to submit a transaction to read state. You could, but no need. So we avoid gas fees there. So let's try to flip it. So pop call contract -- contract, paste the address in, and this time the message will be flip. And this time we do need to execute the transaction. So we're going to execute it. We're going to submit a transaction. We need to sign it. The default address to sign, if we don't specify, is Alice, which is fine for development purposes. Look how fast that was. Okay, so it's done. We can see the events here, the balances palette, contracts palette, it was called. Okay, there was a fee paid. Okay, so it succeeded. So if I rerun the call to read the contract using get, it's now false. Okay, so it worked. So what I just showed you today is just how to use PopCLI to generate a contract from an existing template, how to compile the contract using pop build, and how to deploy the contract. So when we deploy the contract, PopCLI uploads the contract to the blockchain and it instantiates the contract. And then finally, how to interact with the contract by using pop call. All right, thank you.